So here are some differences. Let's discuss first the differences between the mass and weight. Differences between the mass and weight. The mass is the amount of matter contained in a body, while the weight is the force with which a body is attracted towards the center of Earth or center of other heavenly bodies. Similarly, the mass, the SI unit of mass is kilogram, and in weight, the SI unit of weight is Newton. Since the weight is force, so its SI unit is Newton. Similarly, mass is measured by the device which is called beam balance, and weight is measured by the device which is called spring balance. You need to remember while we are discussing here, you have to remember, I can ask you anytime. I can ask you randomly. Similarly, the differences between acceleration due to gravity small g and universal gravitational constant capital G. Look at here, acceleration due to gravity. It is the acceleration produced on a freely falling body under the influence of gravity. Similarly, universal gravitational constant capital G is the gravitational force produced between two unit masses separated by unit distance between their centers. The acceleration due to gravity is measured in meter per second square in terms of SI unit, and the SI unit of universal gravitational constant is Newton meter square per kg square. Similarly, the acceleration due to gravity is variable. It is variable quantity, and universal gravitational constant capital G is a constant quantity. Its value does not change from place to place, but the value of acceleration due to gravity is small g changes from place to place, so it is variable. And the value of universal gravitational constant capital G does not change from place to place. Its value remains constant, so it is constant quantity. Okay, these two differences you remember now. Okay, I ask you, may I ask you? Rest. What are the differences between mass and weight?
Mass is the amount of matter contained in a body. Weight is the force with which a body is attracted towards the center of the earth. SI unit of mass is kilogram. SI unit of weight is Newton. Mass is measured by beam balance. Weight is measured by spring balance.
Okay, so Siddharth Khapril, what are the differences between acceleration due to gravity and universal gravitational constant?
Acceleration due to gravity is produced on a physical body under the influence of gravity. The universal gravitational constant is a gravitational force between the two unit masses separated by the unit distance between them. The acceleration due to gravity is variable. The universal gravitational constant is constant. As a unit of acceleration due to gravity is meter per second. As a unit of universal gravitational constant is a Newton meter square kg
per kg
square.
And listen, you told that the unit of acceleration due to gravity is meter per second, not meter per second. Its unit is meter per second square, because it is acceleration. The unit of acceleration is meter per second square. Okay, so very good. Next, Unisa Maharjan, what are the differences between acceleration due to gravity and universal gravitational constant?
acceleration due to gravity. It is the acceleration produced on a falling body under the influence of gravity. It is the gravitational force between two unit masses separated by the distance between their centers. SI unit of acceleration due to gravity is Newton meter per second square. Acceleration due to its universal gravitational constant SI unit is Newton meter square per kg square.
Okay, good. Now, next concept. You can see here the differences between gravity and gravitation. This is also SE question. Differences between gravity and gravitation. We hear these two terms similar, but they are almost similar also, but in some respect they are different. Okay, what are the differences? Gravity, it is the force with which a body is attracted towards the center of earth or heavenly body. This is just the definition of weight. So the gravity and weight are similar concepts. Okay, so gravity, it is the force with which a body is attracted towards the center of earth, but gravitation is a mutual force of attraction between two bodies in this universe. Okay, the mutual force of attraction, one body attracts the next one and next body attracts the first one. Okay, such mutual force of attraction is called gravitation. And gravitation is also called gravitational force or force of gravitation. Similarly, gravity is also called the force of gravity or weight. Next point is the gravity depends on mass and radius of planet or heavenly body. The factors affecting gravity are the mass and radius of heavenly body. But gravitation or gravitational force depends on the masses of two bodies and distance between their centers. These are the two factors affecting the gravitation. What are these two factors? One is mass of the two bodies and other is the distance between their centers. And so next topic, the differences between free fall and weightlessness. This is also many times asked question. Free fall, when a body falls under the influence of gravity, neglecting the air resistance, it is called free fall. It means the falling of body neglecting the air resistance by the influence of gravity. Such falling is called free fall. If there is no air resistance and the body is falling towards the earth or other planet, then such motion is called free fall. Similarly, weightlessness, the condition of a body in which the body feels that it is not being attracted by any kind of force, is called weightlessness. Okay, weightlessness is the condition of the body where or in which the body experiences that the body is not being attracted by any kind of force. Means there is no any force applied on the body. The body experiences that. Okay, force is actually applied, but the body experiences that the body is not being attracted by any force. This is called weightlessness. And free fall, it occurs in the presence of gravity, but weightlessness, it occurs in absence or in the presence of gravity. In both cases, that weightlessness occurs. Mostly, free fall occurs when there is gravity and there is no air resistance, but weightlessness occurs when there is absence of gravity or presence of gravity. In presence of gravity, during free fall, the weightlessness occurs. Okay, and next point we can also write here, free fall is the cause and weightlessness is the effect of free fall. Due to free fall, the weightlessness occurs. We can write next one also. These two differences, okay? I ask you to remember this and I will ask you. Sital, what are the differences between gravity and gravitation?
Gravity is the force with which a body is attracted toward the center of Earth or a heavenly body. Gravitation is the mutual force of attraction between two bodies. Gravity depends on mass and radius of a heavenly body. Gravitation depends on the masses of two bodies and distance between their centers.
Good. Arambakatil, differences between the free fall and weightlessness.
Free fall, the condition where a body feels the condition where a body neglecting. So once done that, forget.
Differences between free fall and weightlessness. Okay, Unish, Suhana, differences between free fall and weightlessness. Free fall and weightlessness differences.
When a body falls under the influence of gravity, neglecting the air resistance is called free fall. When a body, the condition in which the body feels that no force is being attracted by any force is called weightlessness. It is the cause of weightlessness. It is the effect of free fall.
Okay, weightlessness is the condition in which the body is not being attracted by any kind of force. Okay, this, be clear on this. Priyanka, differences between weightlessness and free fall.
Sir, free fall when a body falls under the influence of gravity, negating the air resistance is called free fall.
Good.
The condition of a body in which the body feels that it is not being attracted by any force is called weightlessness. Free fall, it occurs in presence of gravity. It occurs in absence or presence or gravity.
Of gravity. Good. Okay, now next important point question is the differences between fall of parachute on moon and fall of parachute on earth. This is also a C question. What are the differences between falling of parachute on moon and falling of parachute on earth? Here are some differences. Fall of parachute on moon. This is free fall due to absence of air resistance on the moon. There is no air resistance on moon, so the falling of parachute on moon is free fall. But there is air resistance on earth, so the falling of parachute on earth is not a free fall. This is not a free fall due to the presence of air resistance on earth. Next point is the body feels weightless during this condition. Okay, in fall of parachute on moon, the body feels weightlessness. During free fall, the body feels weightlessness. So, but body feels some weight during this condition. When the body falls with the parachute on the earth, the body does not feel the weightless. Okay, it feels weight. So these are the differences. Remember that. Now, these are the differences, mostly asked differences in SE from the chapter force. Okay. I'll ask you. Nivina, what are the differences between the fall of parachute on moon and on earth?
Fall of parachute on moon is free fall due to no air resistance. Fall on parachute on earth is not free fall due to air resistance. In this condition, fall on parachute on moon is the weightlessness. and
Hmm?
a fall on parachute on earth is not does not feel weightlessness.
Fall off. Okay. Dev. Yes, Dev, who is taking video there. Okay. Someone else is taking video in this class. Okay. If you need, I'll provide the video. Okay. You can see in YouTube. Okay. Tell your friends or who is there. Okay. And so Dev, yes, what are the differences between falling off parachute on moon and on earth?
Falling on parachute on moon is the free fall due to the absence of air resistance.
Mhm.
Falling off parachute on earth is not fall due to the presence of air resistance. Body feel weightlessness during this condition. Body feel weight during this condition.
Have you seen there in your copy? Put in your mind, okay,
No,
not in copy, okay? Yes, write in copy, but you should remember, okay? You have to write an exam. So the next, from pressure, from the chapter pressure, we have some differences that force and pressure. What are the differences between force and pressure? Read that. Force is an actional agency that changes or tends to change the state of the body from motion to rest and rest to motion in a straight line. But the pressure is the force applied per unit area. The perpendicular force applied per unit area is called pressure. Next difference is the SI unit of force is Newton. The SI unit of pressure is Newton meter square or Pascal. Okay. These are two differences. You should remember that. And next is the differences between density and relative density. This is also frequently asked question, many times asked question. Density and relative density. What is the density? Density of a substance is defined as the mass per unit volume. The mass per unit volume. But the relative density of a substance is defined as the ratio of density of substance to the density of pure water at 4 degrees Celsius. This is the relative density. Next point is the SI unit of density is kg per meter cube. But relative density has no unit as it is the ratio of two densities. Okay, it is the ratio of density of substance to the density of pure water at 4 degrees Celsius. So having same physical quantity, it has no unit. No unit. These are the two differences. Saksham. Saksham. What are the differences between force and pressure?
Force is an external agency which changes or tends to change the state of body. Pressure, the force per acting unit area is called pressure. Force, its SI unit is Newton. Pressure, its SI unit is Pascal.
Good. Pravesh Khatri, what are the differences between density and relative density?
Density, relative density, the ratio of density of strength to the ratio of density of water at 4 degrees Celsius is called relative density. The density of a substance is defined as forgot.
Samriddhi Sai. Samriddhi, what are the differences between density and relative density?
Density is the mass per unit volume. Relative density is the ratio of density of a substance to the density of pure water at 4 degrees Celsius. Density's SI unit is kg per meter cube. Relative density has no unit.
Okay. What are the differences between force and pressure? Samriddhi.
Force is an external agent that changes or tends to change the state of a body from motion to rest or rest to motion. Pressure is the force per acting unit area. As Forces SI unit is Newton. Pressures SI unit is Pascal.
Okay, rewards, Mr. What are the differences between force and pressure?
Force is an external agency that changes or tends to change the state of a body. Pressure is an force applied per unit area. Force SI unit is Newton. Pressure SI unit is Pascal.
Pascal, very good, good. Okay, then we go to the next concept, that differences between Archimedes principle and law of flotation. Archimedes principle and law of flotation. You see here, Archimedes principle states that when a body is wholly or partially immersed in a liquid, it experiences an upthrust which is equals to the weight of liquid displaced by it. This is the statement. Law of flotation states that the weight of floating body is equals to the weight of liquid displaced by it. This is the statement of law of flotation. Archimedes principle, this principle is used to calculate upthrust. Law of flotation, this principle is used to make hydrometer, lactometer, etc. Ship, it is used in, this principle is utilized in floating the ship. Okay, so remember this concept. Differences, I'll ask you. Prince, what are the differences between Archimedes principle and law of flotation?
Archimedes principle states that when a body is fully or partially immersed in water, it experiences an upthrust which is equal to the liquid displaced by it. Law of flotation states that the weight of the floating body is equal to the weight of liquid displaced by it. Archimedes principle is used to calculate the upthrust. Law of flotation is used to make the hydrometer or ship.
Very good. So, Avesa, differences between law of flotation and Archimedes principle.
Law of flotation states that when the body's law of flotation states that the weight of floating body is equal to the weight of liquid displaced by it. Archimedes principle states that when a body is wholly or partially immersed in a liquid, it experiences an upthrust equal to the weight of liquid displaced by it. Law of flotation is used to make a hydrometer. Archimedes principle is used to calculate upthrust.